we are going to discuss about scene text recognition using deep learning. Then we are going to see about the overview of our project. The main objective of our project is to recognize the scene text by using deep learning, then auto-encoded and OCR. Okay. In recent years, scene text recognition has received much attention and has a wealth of application scenarios such as photo translation, image retrieval, scene understanding, and so on. However, the text in the scene is also faced with many problems such as light changes, deformation, text string recognition under background noise interface, text skew and degree of curvature, and a large number of artistic fonts. Solving the above problems will always be a challenging thing. This system reviews some recent work on text detection, text recognition, and end-to-end text detection and recognition, and finally look forward to the future development direction. Natural text scene images contain important semantic information such as names of streets, institutes, shops, road signs, traffic information, etc. The most of the state-of-the-art text image recognition methods are based on template matching, which is also the case of most available commercial OCR systems mainly designed for printed text. The system is developed the different deep learning algorithms such as ResNet for classifying the text and auto-encoded for extracting the features from our datasets. Then the result shows that scene extraction from the input image, as well as we have estimate some performance metrics such as accuracy, precision, and specificity. So this is the overview of our project. Then we are going to see the flow diagram. So this is the flow of our project. First we have to take scene text image dataset as input. So we have to choose or select any one image from our dataset. The selected input image are carried out to pre-processing step. Here we are going to implement or resize our input image as well as grayscale conversion. The pre-processed image are carried out to feature extraction module. Here we have to extract the features by using auto-encoded. Then the extracted feature image carry out to text recognition. So here only we have to extract or recognize the scene text by finding counter region. Then classification. So here we are implemented ResNet for classifying the input image. Then finally prediction. So here we have to predict or extract text from input image. Finally we are estimate some performance metrics like accuracy, specificity, and sensitivity. So this is the flow of our project. This is the demo of our project output. We are running our project in Spider IDE from Anaconda Navigator. So this is the input image which is selected from our data set. Then we have to resize the input image. Then we have converted the input image as grayscale conversion. Then we are implemented auto encoded for extracting the features from resized or pre-processed image. So this is the original image. So after reconstructed image, so This is the feature extraction module which we're implementing autoencoder. Then we are extracted the text from original image, finding some counter regions. Then we are classification module. Here we are implemented ResNet algorithm. So with the help of this algorithm we have to classify the image. So these are the layers which is present in ResNet. Then finally we are estimate performance analysis like accuracy. In our project we got 96% accuracy, then specificity, then sensitivity. So this is the output of our project. Thank you.